first. So thank you. Absolutely. Good morning, everybody.
Good morning.
You're very soft-spoken for the folks in the back. You can't tell. Matter of fact, the Citizens Water Academy is now open for registration. So if you've got a little plug of interest there, be sure to check that out. But I'm here to talk a little bit different of a topic today. We're going to talk about aquatic plant management in Lake James. A little bit more specifically, Hydrilla. You guys didn't plan that at all to put them in front of me. It's a really good intro right there. We're going to talk about some of the same places. All right, I'm an old extension agent instructor, and I love a good pretest. Most folks are bored to tears with aquatic plants. We're going to start with familiar things to many people in the room and talk a little bit about the difference in native and non-native systems. Notice I didn't say invasive. I said native and non-native. Play amongst yourselves. I don't want anybody to get embarrassed, but we'll start with 5 of the more common sunfish species that we have in the Catawba River system. Native or non-native? Believe it or not, what's that now? To the watershed, and some watersheds. See, he's on to me. This is all USGS based. You might be surprised to find out that 2 of the more common species that you can find in the Catawba River, the red ear sunfish, the green sunfish, are in fact non-native. Let's make it a little bit more fun. Different catfish species. Nobody cheat. Keep your mouth shut. Blue catfish, flathead catfish, and channel catfish. Native or non-native? Oh, non-native. Ooh, Jack, I told you. You're going to embarrass yourself. Believe it or not, we don't have any native catfish species to the system. Bullheads, however, are native. You may have heard of the white catfish. Anybody recognize that sign behind this gentleman? Yeah. You guys are the proud owner of the white catfish state record in North Carolina, which is 13 pounds. Sorry, but the white catfish is also a bullhead. So I'm going to skip through this to save on some time, but also some similar looking species, the common carp. Common carp, great story. I could spend about an hour and a half on that one and how it got here. The common carp and the grass carp are non-native. Smallmouth buffalo and robust red horse, similar looking species, are native. So now, why I was telling you about native and non-native is, does non-native equal invasive? Not necessarily. You have to be both non-native and economically or environmentally damaging to a system. Believe it or not, less than 2% of our introduced species become invasive, but they are incredibly costly. So on to Hydrilla, which the folks with Professor Holbrook's lab talked a little bit about today. Incredibly aggressive species that is both non-native and invasive. We have 2 biotypes, one that came from Sri Lanka and one that came from North Korea. We're lucky enough to have the one from Korea here, the Monoecious biotype. Came over in the 50s and 70s. The Florida variety is a little bit different than what we have here and has pretty much wreaked havoc across the state since. How did it get here? The aquarium trade. I believe it was marketed as Indian stargrass when it first came over. It looked great in an aquarium until it filled it up and off into the ditch it went. Hydrilla in Florida took over the entire state by the 1970s. They don't have a single ounce of water that hasn't had Hydrilla in it at one time or another. It's beautiful. Like most invasive aquatic plants, it's gorgeous when it stands by itself, but in a reservoir system, as you can see in the bottom there, that is not a pasture. That is open water full of Hydrilla. So they call it the perfect aquatic weed for many reasons. There's usually somebody in the audience. I'm going to cut you to the chase here, and they'll say, "Hey, why don't we just feed it to cat? There's got to be biofuel opportunities here." Well, this species is about 98% water, so you can pull out several thousand pounds and literally have just ounces left over at the end of the day. It can grow in a wide variety of conditions, much like ambusia that you guys were talking about. And unlike a lot of plants that folks are familiar with, the main reproductive mechanism for Hydrilla is fragmentation. So any little piece that's broken off and has leaves attached will form roots from those leaves at the node. To make things even worse, they have these little survival structures called tubers and turions. Tubers are a little more important. That's the little potato-looking structure there on the bottom. In a section about as big as where I'm standing, each year Hydrilla can put as much as 900 tubers in sediment, and they can be dormant for up to a decade. The old adage used to be 1 inch per stem per day. One of my colleagues, you actually had a picture of the late Dr. Mike Netherland, was in the U.S. Army Corps of Engineers photo. Actually found out it's about 144 square inches per student. So what's the big deal? There's tremendous ecological impacts that can outcompete native species, cause those fluctuations in dissolved oxygen, alter the food web, but it also has major economic issues with it as well. For us at Duke Energy, it can clog water intakes, it can clog dams. It certainly reduces or halts public use and can be pretty wide-reaching on how it impacts the economy. Just some photos here of some aquatic plants impacting some of the structures that I talked about earlier. This is supposed to be a public swimming area. This is supposed to be a public boat ramp. You're not doing much in those scenarios. So why are they so bad in reservoirs? Anybody take a shot at that one? These are man-made water bodies. So we've essentially created these large systems with a lot of shallow water habitat, and guess what? No competition for the native plants in these reservoir systems. Oaks and pine trees, previous to it being water. So we also have traditionally higher levels of nutrients. And a lot of these plants have a competitive advantage. For example, Hydrilla needs right around 1% of sunlight. It's the first one to wake up in the morning and start photosynthesizing, and the last one to go to bed. So it does a really good job of competing with some of these other plant species. So I talked a little bit about tubers and how they function. Usually when Hydrilla comes into a system, it goes unnoticed for the first year. So in that first year, a small little section will lay down some tubers. By year 2, maybe it's in the back of a cove, Patty's Creek, for example, but it's still away from a lot of recreation. People are noticing it, but it's not causing any impact. Or tubers. On into year 3, well, now we're blocking the state park, for example, swim beach. Somebody makes a call to North Carolina DEQ, says we've got Hydrilla. They come out and do a treatment. What's the problem? What's still there in the sediment? And for how long? Up to a decade. Okay, everybody's listening. Fantastic. So when I was at NC State University, we were looking at the viability of the reproductive capacity of fragmentation, especially at tubers. When those tubers stick their head out of the sediment, producing some of that biomass, if you clip them, if you cut them, how long are they going to last? Is that a viable means of control? Everybody in the room should know the answer to this. We'd like to serve them up on a platter and make sure we've got really good results there at the end. We clipped them. You can see on the left there for the folks in the audience, that's the initial tuber, and on the right, you have the clipping, which has now formed roots. The team that did this clipped these things 10, 15, 20 times, and they just kept spitting out vegetative biomass. So moving on to kind of Duke Energy's history with Hydrilla in the system, we have our initial infestations, which you can see in black, our re-infestations, which you can see in blue, and unfortunately in red, the re-infestations. Nobody checked Webster for that. I think I made that one up. But we have a long history of Hydrilla issues in the system, starting with Lake Wateree, followed closely behind by Lake James. If any of you were around in 1999 during that initial introduction. This is the Catawba drainage area, right down from the wetlands you all look at the upper end, about 600 acres in 1999. So whose responsibility is it? That's usually the question I get, usually from somebody not terribly happy on the phone. What's Duke Energy going to do? In both states, in North Carolina and South Carolina, invasive aquatic plants are regulated by the state agencies. North Carolina, it's DEQ. South Carolina, it's DNR. They have a really great cost share program where they match dollar for dollar with local contributions for any management activities, but they won't do it on their own. In other words, there has to be local buy-in. In this case, Duke Energy is one of those local partners, and myself and my colleague, Ms. Erin Malloy up there, we spend a lot of our time facilitating all the other local partners, getting everybody on the same page and getting a management plan put into place quickly. So in aquatics, we have roughly 5 buckets that we pick from as far as management. You know, how do we get rid of Hydrilla is usually the question. The most effective, anybody want to take a shot? Preventative. Preventative. Least used. Preventative. Yeah. So that is what our team spends most of our time doing. If you live on the lake and you cursed at the loud airboat that went up and down the lake a few times over the last few years, that was in most cases us. We have to use that to get back into some of those really shallow water areas because that's where Hydrilla likes to rear its ugly head first. So we do a lot of surveys. We use hydroacoustics and our folks on board to make species determinations. Once we find hydrilla in reservoir systems, the most often used control is biological control. I briefly covered grass carp earlier. Grass carp are a tremendous tool when it comes to managing aquatic vegetation. There's a caveat. We're talking about triploid grass carp, which is a technology developed in the late 1980s. We essentially render these fish sterile. There's only 2, maybe 3 producers in the state of Arkansas. All your fish that have been in Lake James came from Arkansas. And they undergo a very rigorous process that's regulated by the U.S. Fish and Wildlife Service to make sure that we don't have grass carp that make more grass carp. There's nothing worse than turning cows loose in the pasture when you can't get them back out. They keep making more. That can be a problem. So grass carp is most often our tool that we use. So very briefly, I'm going to talk about hydrilla, our history over the kind of recent time frame. The wetland area, I believe you guys call that the large wetland complex or something like that. We first found hydrilla in this very upper end in 2020, roughly about 11 acres. We had the wonderful folks from the LJA, you see Sophie and Jack there, help us actually carry grass carp in trash cans from Burnett's Landing up there and stock those in that small wetland area. They did a fairly good job, but we were a little bit behind. Fall of 2021, we started to see hydrilla leaking out in these locations. Everybody keep in mind Patty's Creek right here. That's just kind of odd for it to be that far from that initial introduction. That'll come into play here momentarily. But in fall 2022, this is what we saw. Aaron leads our survey team, and we went from roughly about 17 acres to 116 acres 1 year. It exploded. Many of your members I've talked with sent me photos. This is actually the back of Patty's Creek here. There'll be some management decisions we can talk about that'll be undertaken in 2023. Something that's interesting about grass carp, in most cases when they're stocked, we're not stocking fish this big. We're stocking fish about 12 inches. They have to make it here on an 18-wheeler from Arkansas. So it takes them a little bit of time to get caught up. These things can eat 130% of their body weight a day in biomass, but hydrilla is 98% water. If the most inefficient creature could have been made, it may be the grass carp, because it takes a lot of biomass to keep these things alive. But they do eventually start to have impact. This is fall of 2019 when we stocked that small wetland complex. This is fall of 2021. A lot of these are other wetland plants. What you see here was majority hydrilla. So hopefully you guys can see the transition there. So in closing, I told you to take note of the reinfestations. Does anybody see a trend in the timeline there? For Lake James, you got about 10 years, right? Tubers, how long do they typically last? Okay, so what we're actually seeing, most often the scapegoat is somebody brought it in here on a trailer from far away. But what we're actually seeing, not only on Lake James, but elsewhere in the system, is we have these holdover populations that like to live in these small wetland areas where grass carps can't get to. These shallow 6 inch and a foot, they're separated from the system, but they're the gift that keeps on giving. Our grass carp, because they aren't reproductive, over time, we experience about a 30% mortality every year. So those populations dip, and as soon as they dip, hydrilla finds its way back out of those areas. Patty's Creek is a really, really good example of that. There is hydrilla all the way up the Patty's Creek arm, all the way headed toward the Pisgah National Forest. It's coming from somewhere, but after grass carp herbivory is taken off of those plants, they're finding their way back out into the system. And these are the types of areas, like you all mentioned, that we're finding are the holdovers. They're the places and where we're putting most of our priority now. I forgot to introduce this map. This is hydrilla in 2001. Look familiar? It's very familiar what I just showed you in 2022. So with all that said, what about if we just let it go and let it grow? Well, in Lake James, it may be too deep for hydrilla anyway, right? We started with 17 acres. This is the 10-foot contour around Lake James, which is roughly 1,131 acres. We're at 116 right now. So if you think you're being impacted currently, think about 10 times that amount on Lake James. This is what that looks like on systems where, you know, management has gotten past the point of control. You guys saw lots of posters out front. We do have a success story, yellow floating heart, which is another invasive introduced into the system. We've got great control of the limbal arm there. We have one little holdover population you can see here on the left. But thanks to Jack and a lot of others from the LJEA, we've been able to suppress that population with the North Carolina DEQ and Department of Ag. How you can help, call us. I love getting the phone calls and emails from folks, even when they're usually a little bit angry. You guys are the eyes on the water every day. Aaron and I see these lakes maybe once a year. So you're the early warning system. You see something growing that looks a little funny, give us a call. And that's, I think, all the time I have.
Take one or two. Take two questions.
So does wetland drying kill the hydrilla? I don't even know if it would be cannibal, but like these